Hi and welcome to this Leaving Cert Higher Level Applied Maths video. In this video we're looking at the 2025 exam paper, question 5, part B. This question is about vectors. So we're given a little diagram of a vector with A, and they tell us that A is 14i minus 9j. They then define B as pi plus qj, and they give us two bits of information. They tell us that the modulus, or the magnitude of B, is 21, and that A is perpendicular to B. Calculate the possible values of P and Q. Now, here's the thing. There are two possible answers here, because if we draw in B that's perpendicular to A, it can be up this direction, or equally it can be down this direction. So we're going to get two different answers for B. And that's really, really important. That means we're going to get two answers for P and two answers for Q. So let's work with the two bits of information we're given. The first is that we have the magnitude, and the second is perpendicular. So for the first one, we're going to go to our formula and tables book, or maybe you already know your formula off by heart for magnitude. If you do, that's great. If not, we have it here on page 17 of our log tables. It's called norm. We would call that magnitude. So that is the square root of p squared plus q squared, and that will equal 21. Now, get rid of that square root by squaring both sides. We have p squared plus q squared, 4, 4, 1. And that becomes our first equation. The second thing we're told is A is perpendicular to B. Now, when we talk about perpendicular vectors, again, we can go to our log table and look at the angle between two vectors and talk about that angle being 90 degrees if they're perpendicular and so on. But it's really, really important that you have this nice and quickly. If we have perpendicular vectors, their dot product equals 0. So what we mean by the dot product is if we multiply A, which is 14i minus 9j, by B, which is pi plus qj, then we do 14 by P plus minus 9 by Q, and that's going to give us 0. That gives us 14P is equal to 9Q, and that's our second equation. And what we effectively have at this point is a linear, nonlinear, simultaneous equation that we need to solve, and we're going to get two answers for P and two answers for Q. Okay, so giving ourselves some space, our method is the same as in maths. We isolate, so we'll have 9q over 14. I'm isolating p. Equally, you could isolate q, not a big issue which one you work with. And then we plug that in. What that means is we're going to have an equation now that just has q's. So I get 81 q squared all over 196 plus q squared equals 441. So if you want to get rid of that fraction, let's multiply across by 196, and we get 86436. So a very big number. So 81 plus our 196, that gives us instead q squared, and that equals 86436. So our q squared is going to be 86436 divided by 277. So does that tidy up in any kind of nice way? Nope. So we're just going to square root that as is. And that gives us Q equals 17.66. Now, we said we wanted two answers, so where are the two answers coming? Because we have the squared, remember our rules from maths, so power 2 means there's always two answers. So where are the two answers coming from? Well, you need to put a plus and minus in front of both of those when you're doing your square root. So please bear that in mind. So then to get our P, we're doing 9 times 17.66 divided by 14. So we have 17.66, divide that by 14, and that gives us P equals 11.3 0.35. And again, that's a plus and a minus because we can sub in the plus and we can sub in the minus. So P and Q can give us two values. So the two options for B, I know they didn't ask this, but it'll be 11.35 I plus 17.66J. That would be in the first quadrant here. So it would look like that. There's our right angle and there's our B. Or it could be in the third quadrant, which is minus 11.35I minus 17.66J, which is down here in that quadrant. So there are two answers for B, but the question only asked us for two answers for P and for Q.